here we are back at the Wood Technology Center for another round of our tool series.
And we are. Look at this beautiful tool.
Dave Borgatti, instructor at Wood Tech. We've got our good friend you from Milwaukee Tool joining us today.
Thank you.
Thanks for being here, man. I appreciate
Absolutely.
it.
Thank you for having me.
Yeah, well, we have a state-of-the-art, very nice looking miter saw here today. You want to run us through the basics on this tool?
Absolutely. Thank you. So what we have here today is our 10-inch dual bevel M18 cordless miter saw. This is one of the new to world tools that Milwaukee has pioneered within the industry to provide our prosumers and customers with a cordless solution to a traditionally once corded tool. So typically on the job site in the past, people have typically run these stationary tools off the cord, and it was very cumbersome for them to be able to find a plug and get power and then be able to transport that since it is such a large, bulky tool. We've taken our technology with our drills and motors, put that into our cordless 10-inch miter saw, coupled with our red lithium batteries, as you see over here, and created a cordless platform to be able to provide our end users with a 10-inch dual bevel full compound miter saw. Some of the main features of this miter saw is that you're going to be able to get a full 47.5 degree bevel on it. You're going to be able to actually cut up to a 5 3/4 inch height and a 5.5 inch depth as well when you guys are making those cuts. This button right here is going to be the release lever to be able to pull the saw up, as well as it will provide you a nice smooth transition when you're making that sliding cut. If you are looking for that perfect precise cut, we're going to provide a LED light on the very top of the blade to be able to provide you a shadow line for you to be able to make that cut.
And one thing about the light, this is really important. Jim, a lot of times when you're a finished carpenter, you're setting up in back of something, you're setting up away from where everything's going on. And you often don't have a lot of light. That light is really handy.
Another thing that we have here as an added feature for our miter saw is that we have these two handles. That way you're able to carry it on and off the job site very easily. This provides you also with a full range all the way up to a 45 degree cut and a little bit past. So the full range is going to be that 50 degrees completely when you go from side to side. Mm-hmm. And then for you to be able to move the miter saw back and forth, you're actually going to be using this release lever right here to either lock in or release
whether you want to do that or not.
So the slides actually get retracted all the way. Yep.
Exactly. Yep.
How do you release and rotate for a bevel cut?
Yeah, absolutely. So what you do to release for a bevel cut, I'll go ahead and slide it to the side right here. You're going to go ahead and lift this arm up. That way you're able to move it from side to side.
Gotcha.
And I'm going to interrupt for a second. Unlike my students, you have to also, I'm just going to pull your clamp here.
Yeah.
But you have to retract these. So if you don't retract them, you will, in the words of some of my students, cut right through the aluminum fence as well. So the fence, there we go. Okay. The fence is set up so these things will slide back and forth. In normal operation, if you're not beveling, then you can bring these closer together.
Okay,
yeah.
Gotcha.
Yep, absolutely.
And you probably have a dado set for this as well, in order that you don't have to cut all the way through. Can you show us where that is?
Absolutely. So I'm going to go ahead and lock this in right now, just so it doesn't move. And then I'm going to go ahead and just kind of lock this in as well. That way, you're able to get to the back of it. Your dado set right here is going to be right here, and it'll just adjust up and down. Right there.
Great.
Say, Dave, I know when he's out in the field, your tools are all in and out of your truck, sometimes daily or for sure weekly usually, getting bounced around, banged around. Do these get ever so slightly out of square? And if so, how do you dial it back in and tweak it to where you get that perfect cut?
Yeah, great question. So there's a couple of ways of going about it. The first way is doing it yourself, and how you would do that is by making sure you have a nice T-square and squaring up along the fence, as well as this line right here of where you're cutting, to see how much you're off. From there, you can make some micro adjustments on the tool to be able to get you back to that square. Another way to do it is going through our service center over here in Seattle's Georgetown and having them actually make that adjustment for you.
Dropping off your tool and letting them do it, or
Absolutely.
or is it quick enough where you could drive in and wait for?
Yeah, depending on the confidence level of the user, of whoever is using the saw, if they're comfortable with setting it themselves, there's a full service guide on parts as well as how to adjust and make it aligned right on MilwaukeeTool.com. And then you can search each tool on the website. It'll pull up its actual service brochure and provide you a list of details of how to maintain the tool.
Yeah. Well, you pointed out huge benefits to the cordless tool on the job site, but are there any potential things you're sacrificing from the old corded tools?
You know, with the upcoming or the ongoing improvements that we've been making with lithium ion technology, the gap is very, very narrow. For this specific tool, you're really not giving up much power at all. In fact, you're going to get over 600 cuts off of just this one M18 12 amp hour battery. You're going to get 15 amp corded power when using this saw. So as far as power goes, when you actually use the tool, you're not going to notice any type of decrease in power when you use it. And in fact, because of the time savings of not having to find a cord or find a plug and drag the cord out and drag it back, ideally you'll be more productive and save time on the job site.
Yeah, that totally makes sense. Dave, in watching you cut a few pieces here the other day, it seemed like there was definitely a method to the madness. You know, a lot of people are probably just used to their miter saw just going up and down. You say this being a sliding miter. It was interesting watching you. I mean, you took it back, and then is it kind of a blended motion of forward and down at the same time? And
You know, actually, this is a miter saw and a slide compound miter saw. So if you're doing small pieces, what we recommend is bring the slide all the way back and not using it.
Boom.
In other words, there's a lock for the slide.
Yeah.
And we can show that, and we can show the difference between a miter and a bevel when we've got her up on the stand. Slide compound saws are great. I would imagine when you pull it out, what have you got, 13? How many inches do you have when you pull it out?
You'll have a full 13 and a half
Full
inches
13 and a half
when
inches.
you're going to go pull it out. And what we recommend is that you actually pull it all the way out, and then you start the saw first.
Okay.
Then once the saw is in full rotation, you go ahead and push it down and then push it in.
so all the way down and
All the
then
way
slide
down
it
and
forward.
then forward.
Because if you think about it, you're pushing into the fence the safest way.
Yeah.
And the blade rotation is like this. So what happens is, if it were to catch, like the old radial arm saws, we used to call them radial alarm saws because they would catch and come out at you.
Yeah.
But this way, as you saying, if you're already out there and you plunge down and are pushing forward, you're right behind the tool.
Yeah, I like that. Great tip.
What I normally do when I take it out of the truck and I set it on the stand, you has kindly brought a stand, and this is one of the biggest things that I recommend. It's rather like when you're using a table saw. Setting up a table saw with no outfeed table is insane, okay? Because you have no outfeed support. Here, he has lateral support on a stand. So I really believe that when you buy a saw, you should buy the stand too.
Good tip. Well, thanks for bringing us. What a beautiful tool. As you mentioned, this is your 10-inch model. Do you have different size models in this series?
We do, yeah. Thanks for asking that. This model is actually our middle tier saw. So we have a 12-inch saw, and then we have a 7.25-inch saw as well. All three versions are 100% cordless. The difference between the three saws is that your standard 12-inch saw that is going to cut some of your most standard basic pieces of lumber, your 4x4s, 4x6s. This saw will actually do that job too, but to a smaller scale. So instead of getting that additional 2 inches cut depth, you're going to get 10 inches with this one, right? And then we also have a smaller 7.25-inch compact saw, mainly for like crown molding, very small trim cuts for your smaller projects.
Okay. So the sizes you guys are talking about, they reference the size of the product you can cut through, or do they reference the size of the blade, or?
Well, you have a good point because you have height and you have depth. Some things, if it's like a 1-by, can be laid down in the flat, which is how that should be cut on a sliding compound saw. But depending on what you have and the size, you may actually literally, and this is one of the things the users do. If you've got something like a 4x6, you may want to go out, turn it on, and then go down slowly. You don't go down all the way and go in. We find that it seems to cut a little better. Every saw is a little bit different, but with sliding compound saws, you do have to play with it to make sure that you get the best cut. What Milwaukee's done here is they've given us a thin curved blade. So you want to treat those gently because it's a narrower curve. What it also means is you'll get more cuts because it's not taking away so much wood.
Okay. Could you touch a little bit on dust protection options? It looks like this has something fixed to it, but maybe there's some other things that you can do as well.
Absolutely. Dust is a huge major issue on the job site. We provided a dust bag standard that comes with the tool. We also have a few different other solutions to be able to provide you with a vacuum solution as well. One of them is cordless, and then the other one is a corded, and both come with a HEPA filter.
Well, this is a good sized tool. We've got the 12 amp battery on there. How far down can you go in battery size with this type of tool?
Great question. For our battery platform, the great thing is everything is forward and backwards compatible. So all of our older M18 products, they're going to be able to be used with our newest M18 batteries and vice versa. So even some of our newest tools will be compatible with some of our oldest batteries or lower amperage batteries. So I like to think of batteries as a gas tank. The higher amperage battery you have, the more fuel you have in the tank to do the job. If you're in a pinch, you can definitely use some of our batteries that are of a lower amp, such as our 2 amp hour, our 3 amp hour XC, or our 5 amp hour to get the job done. Depending on how often you want to change the battery out is going to be dependent on which battery you use. So the 12 amp hour battery is what we recommend for using this 10-inch miter saw. It's going to give you 600 cuts in 2x4. And if you use a lower amperage battery, such as a 2 amp hour, I would just factor that down to probably around 80 cuts or so.
Yeah, that's great to know. All right, well, let's get on to cutting. Well, Dave, looks like you're pretty much ready to go here. Do you want to run us through the setup procedure?
Sure. Well, especially if you just pulled it out. I really like this stand U. This is beautiful. It's a beautiful piece of tooling. I'm going to turn on the light just because I like seeing the light. And it also illuminates what we're doing on the table. The first thing you want to check, apart from having a steady stand and everything else, is just the operation of the tool. The most important thing here is the guard. If the guard hangs up like this, you stop. Okay? It's just not worth it. So the guard operation is number one. I'm going to turn on the light just so that we can see what we're doing here. And I'm just going to move it, and this saw is absolutely beautiful, okay? Now, just to let you know, in terms of the way this slider is set up, you can, by simply locking the rail lock here, go ahead and make this, and you have now turned this in to nothing but a miter saw, okay? But go back here, release it. Now it is a slide compound saw, okay? And, you know, coming out of the truck and everything, Jim, the thing that I worry about is that things got bumped. Yeah. And what I will do at the beginning, apart from making sure that everything is nice and in line, my fences and all that are nice and tight, and I'll leave our slider off for a minute. Okay, so I'm just gonna make it just a miter saw, is I'm gonna make a cut. And then I'm going to measure the bevel and the miter. So let's talk about that for a second. The first thing is this is a miter saw, standard miter saw. These are the first ones that ever came up. Normally went from 0 to 45. This one is nice because it goes more like almost 50 degrees to 60 degrees. So you can get some pretty steep miters. And this is just mitering. Okay?
Does that have a couple other preset positions as you go?
Yes. Now it has what we call detents. Detents just means a hole. So what'll happen is I can move it, and if I want 15 degrees, it locks. If I want 22 and a half, it locks. If I want 45 or 31.7, which is a crown molding stop, it locks. Or I can go to 45 and it locks. Sometimes I want to turn this off so I can get very close to like 23 degrees, which is really close to that 22.5. Okay. So I should be able to just rotate that down. Now I've got it. And you'll hear there is no detent.
Yeah.
Okay, you've eliminated the detent. And then there's a lock by going down like this, which will lock in that. But all we're doing is mitering now. Okay? Now, if on the other hand, I will put the detent back in again and it locks. If I move our fences back here, and the wonderful part about this, Jim, is it's a dual bevel saw. So if I have a long piece of molding, rather than having to flip the whole piece of molding around and set it on the other side, I simply change the bevel on the other side. And so what I'm imagining is then, and you see I'm coming straight across here, this is a bevel. And this confuses a lot of people. So you have the miter table moving and you have the head beveling. Those are two things you got to check right away, okay? Because again, we moved it in and out of the truck. So I'll lift this up again, move it back to 0 here and lock it in place. And again, I've got this on miter only. I'm going to move these in because we won't really be doing too much beveling.
Is that a safer position for the fence if you're...
Yeah,
just
it
in
is
the miter
because
mode?
we'll show you, because basically you have things backing up the cut. So, you know, if you are doing a miter in this fashion, you have those closer in. There are, however, a lot of add-ons that we make, okay, you know, that a carpenter will make on site. And one of them is an L-shaped sacrificial fence. And then the work is completely supported and you never have any issues, okay? So right now, I've got it on a 0 degree miter. I've got it what I believe is on a 0 degree bevel. Yeah. I turn my light back on again. And then I'm gonna take something flat and square, and I can check it, see it's flat, see it's flat. What I'm gonna do is cut it, okay? So, this is a really important part. If you're doing a lot of cutting, you wanna go down, let your finger off the trigger and let it kind of die. Not all the way, but you want to let it kind of die. This is nice, because it has a bit of a break on it, all right? What happens is as the saws get older, they don't have much of a break. Yeah. And then what you'll do is you'll do it two ways. First, I'm going to check the miter and see that it's 0 degrees, and it is. And then I'm going to check the bevel, and it's 0 degrees. Now, don't expect that, okay? Because a lot of times when we pulled it out of the truck, something will be a little bit off. Yeah. Once you've got this adjusted, then if you go for 15 degrees, you know it is dead 15 degrees. But if this is off, it's not. So this is the first thing you want to do, is just make a square cut, check the bevel and check the miter and make sure that it's right. And
that's an everyday practice. If you're moving your tools in and out every day, you want to do that every day.
Well, you were also right. Sometimes we're only doing this once a week. Okay, loading off the site and loading on. So then if it's set up, it should be fine. But honestly, finished carpenters are incredibly retentive. And what you'll find is they'll start at the beginning each day, making sure it's dialed in. Because I have cut a stack of parts one time and it was about a 1/4 degree off and nothing really fit. And that's really sad. So on this, looking at some other parts of this, let's talk about this for a second. I'm going to do a miter here. If you lift up really quickly, that little piece will go up and fly, okay? And that's what you don't want. So if you go down, plunge down, let it die a little bit before, it'll work really well. Now, and there's a really big reason for this. For a lot of people get really confused, and it's an easy way to show it too. If I make a square line, Jim, okay, and I'm going to bring it back to 0 degrees. One of the first things that we teach the students is how to cut a line in half. All right. So what you do is you come out of the line. And you make a cut, and you find that we haven't actually cut the line. Now, the way that you cut a line in half is the design of the blade. The blade is a flat plate, and it has chunks of carbide on there. The chunks of carbide sit out a little bit. It is the difference between, say, for a hand saw set, we bend a tooth left, bend a tooth right, the whole thing. What we're doing here is we're using the thickness of the carbide to show us how to do that. And all you've got to do is what we call kiss the blade. Come down, set in. Can you hear that? So let me do that again. That sound is the sound of the carbide teeth, and it's making a little ring in the blade. So when you do that, you can, what we call sneaking up on it. And you cut off about 128th to 64th, and you can cut your line right in half. That's really important when you're sneaking up on a miter and trying to get it just right.
That's
okay.
Tip.
So this kind of thing is something that we all do, and we all just just check out. But it's one of the first things that I teach as well.
Dave, earlier we were talking about a few safety tips. Do you have a couple more you could share with us?
Absolutely. I think the number one thing, Jim, when we start to look at this is how close you get your hands to the blade. Now, you provided, and all the manufacturers provide a clamp. Sorry, but no one uses them because you're usually holding it on with your hand, okay? Yep. There are several things. First off, a lot of people will hold in, that's wrong. A lot of people will hold down, that's wrong. You want to hold in and down because you're holding down to the table and you're holding into the fence. But the problem is on a miter. So let me just go over here for a second. You can see, and I'm just going to put this down. You can see my hand is very, very close. Yeah. We never get our hand closer than one fist. Okay? That's it. Also, if you'll notice, I'm holding it on this side, and this is a real problem. One of the things that we tell all students is no cross-hand holding. So watch. Because we're so right dominant, we want to do this. And it's actually responsible for a lot of amputations. Yeah. You never cross-hand hold, ever. But it's very easy with these tools because this is such a great handle, such a great switch. You simply go. So if I want to make this miter here and it's close in, well, why don't I simply go over here and cut with my left hand? Okay. So then when you plunge down, let it die a little bit and then bring it up. Nice break on this tool, very nice break. On a lot of the corded tools, after they've been used for a while, Jim, it'll take 15 seconds before that blade finally stops. And what happens is these small pieces of miter, as you're trying to sneak up on something, will end up flying quite a bit. Okay, so that's a really big one, is where you hold your hands.
I noticed you did not have your fingers over the back of the fence.
No, I usually, because I'm trying to hold down, if I have my fingers over the back, all I would be doing is holding into the fence. Okay. And I wouldn't be pushing down. Okay. All right. Now, a couple things that are really interesting. You'll see that there's a large gap here. I'm going to just set it back to 0 degrees here. And there's a large gap here. And this is a problem because what will happen is the fibers as they go through are unsupported. And this is a piece of fur, so we should be able to see this pretty easily. And what you'll see is a rather rough edge there, rougher than most finished carpenters want. So it's so easy to stop this. All you've got to do is have another piece of wood behind it, which we'll use right here. And now, you have very little tear out on the back.
Wow.
So any kind of tear out, and fur is really known for that. You'll have a lot of fibrous kind of work. Having a backing board makes all the sense in the world. Now the backing boards that we do here are actually L-shaped, Jim, like this. And then when you cut through at a miter angle, you can see that you now have a 0 clearance cut. So this, in other words, we biscuit these together and we make a series of L's, if you will, enough that we can still see our miter gauge as such. And that way, when we go to make another cut, it's completely supported. As we talked about before, because the saw has to bevel, this here has to be wide enough to accept it without cutting it. Right? So that's the way you get really clean miters. I mean, Yeah, you could take this to a framing site and it'd be perfectly fine, but it's a beautiful tool. And frankly, this is not something I'd use at a framing site. It's something I'd use at a finished site. I'm looking for the cleanest, best cuts I can get.
Yeah.
Okay? Right now, this is not a sliding saw. But what I'm going to do is I'm going to release the guide rail lock here. And now it becomes a sliding saw. And the way you should be doing this, and I'll take a wider piece here, out, turn it on. So you're pulling it all the way out, coming down, and then sliding in. But this is big, doing it on the flat. So watch, and this is, it's come up recently, I don't know, every now and then you'll get a rash of students doing something that's really dangerous, and because this is non-intuitive, we have to teach this. And that is that they'll use the slider and slide into something vertical. And that's dangerous. That thing will explode. Okay? So you never slide into a vertical piece. You miter it, that's perfectly fine. But if you're sliding, it's got to be down on the flat. Otherwise, it gets really dangerous.
Makes sense. What range of materials can you cut with this thing?
Really, all kinds of materials except anything containing iron. So ferrous metals are absolutely anathema, because what's going to end up happening, you're going to start a fire. Even if you cleaned everything out, it's amazing what it's better to use a metal cutting saw and something like that. But you can use this for aluminum. You can use it for brass, corian, or any of the solid surface materials. It'll do a great job. You just have to match the blade to the material that you're cutting.
Well, thank you again for joining us and bringing this beautiful tool. I know Dave had a great time using it. And Dave, thank you for all the tips, for quality work, and most importantly, safety. Really appreciate that.
Thank you, Jim. Thank you.
No problem. Thank you.